Are there emerging research directions that focus on overcoming the inherent limitations of Nickel-2 for practical sodium-ion battery applications? How does the crystal structure diagram of Nickel-2 illustrate the fundamental arrangement of its atomic layers? What role does the layered structure play in determining the sodium-ion transport pathways within Nickel-2? How does the stacking of cobalt oxide layers influence the electrochemical behavior and stability of Nickel-2? What are the key differences between O3 type and P2 type layered structures in Nickel-2, and how do they affect sodium-ion mobility? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the crystallographic orientation of Nickel-2 impact its electrochemical activity, and are certain crystallographic planes more favorable for sodium-ion migration? What phase transitions occur within Nickel-2 during cycling, and how do these structural changes influence long-term battery performance? How do defects in the crystal structure of Nickel-2 impact its capacity retention and degradation mechanisms? Is there a relationship between crystal symmetry and voltage profile during charge and discharge processes? How do external factors such as temperature or pressure influence the stability and performance of Nickel-2 as a cathode material? What techniques are commonly used to study the crystal structure of Nickel-2, and how do these methods help in understanding its behavior in sodium-ion batteries? How does the presence of sodium vacancies affect the electrochemical properties of Nickel-2, and can these vacancies be controlled or optimized for better performance? What doping strategies have been explored to enhance the structural stability and electrochemical capabilities of Nickel-2? How does the interlayer spacing in Nickel-2 impact sodium-ion mobility, and are there ways to optimize the spacing for improved performance? What challenges exist in synthesizing Nickel-2 with a uniform and defect-free crystal structure, and how do synthesis techniques impact its final electrochemical properties? How does Nickel-2 compare to other sodium-based cathode materials in terms of structural stability and electrochemical performance? Are there alternative structural modifications that could improve the sodium-ion intercalation and deintercalation processes in Nickel-2? How does the presence of water or other environmental factors affect the crystal structure and electrochemical behavior of Nickel-2 in practical applications? How does the value of X in Nickel-2 depend on the control of oxygen vacancies, and what mechanisms govern this relationship? What role do oxygen vacancies play in adjusting the composition of Nickel-2, and how does this impact its electrochemical properties? How does the synthesis of O3-NO-CoO2, O3-No.77-CoO.96, and P3-No.6-CoO.92 depend on the precise control of oxygen vacancies? What?